Okay, so let's get the solutions for the mixed hypothesis testing problems. All right, so in the first one here, we have a claim that 87% of driving aged Americans have a license. Okay, so the first question they ask, is this a claim about a proportion or about a mean? This is clearly 87% of the people, so this is a proportion. Part B asks the question, what are the null and the alternate hypotheses here, right? So this is an equal to type claim, right? 87% of driving. So the null hypothesis here is that the proportion is equal to 87%. And the alternate hypothesis then is that this is not equal to 87%. So the next question is one that we're familiar with, is this a left, right, or two-tailed test? This is two-tailed because we have a not equal to in the alternate hypothesis. And then they give us some sample data. They tell us that they take a sample of 500 driving age Americans. 415 of them had a license. And question D is asking me, like, well, what type of test can I do here? Can I do a p-value test, or can I do both options? And in this case, this is the both. When you have the two-tailed test, you can either do a p-value or you can do an interval test. Either way is good, okay? So in this case, if you are doing the interval test, you're going to use the 1 proportion z interval. If you are doing the p-value test, you're doing a 1 proportion z test, right? All right, so the next question is to actually conduct that test and get the appropriate p-value or the appropriate confidence interval. So let's go ahead and do that. Okay, so what I'm going to do here is I'm actually going to do both the p-value and the interval. So to get the p-value, that's stat test 1 proportion z test. We're testing against 87%. We were told that there were 415 people with driver's licenses out of 500. We're doing a two-tailed test and we calculate. So my p-value here is going to be 0.0078. Okay, so when we get back to the sheet, we'll record that. You can also do the interval for this, and so that would be stat tests 1 proportion z interval, and again it's 415 out of 500 with a 95% confidence interval. It tells me that I'm between 0.79707 and 0.86293. So let me go and record that on my sheet. Okay, so this is part F of the question, which you either have to write down the p-value, which is what you got from the 1 proportion z test, which was 0.078, or you have to write down the interval, the confidence interval here is 0.79707 to 0.86293. Now, G asks about the null hypothesis. So both, like, the p-value here is clearly less than 0.05 and 0.87, not on the interval. So both tests are telling us the same thing, that we should reject the null hypothesis, which means part H, the data does not support the claim that 87% of driving age adults have licenses. Alright, so that's problem number 1. Okay, so claim number 2 is that on average, teachers on average make more than $58,000, and it is known that the standard deviation for American teacher salaries is 8,400. So let's start here. This is a claim about a mean. Okay, it's an average salary. So we get the null and the alternate hypothesis. The alternate hypothesis is the claim that the mean is more than $58,000. The null hypothesis is that it's equal to. Okay, so part C is this left, right, or two-tailed. This is going to be a right-tailed test. Because it is a right-tailed test and not a two-tailed test, you can only determine this by using a p-value. Okay, part E asks what's the appropriate test here. The appropriate test is actually a z-test, because we have the rare circumstance here where sigma is known. So because we know what sigma is for the population, we can actually perform the z-test instead of the t-test. Alright, so let's actually perform that test. Alright, so we go stat test, and we're doing a z-test. And now we're going to use statistics, not data. We're testing against a mean of 58,000. Sigma, we're told, is 8,400, right? The sample mean that we got there was 59,170. And the number of people in this sample was 100. Okay, so this is a right-tailed test. We calculate, oops, not sure how I got there. Right tail, we calculate, and we get a p-value of 0.0818. Alright, so let's work with that and get that over to the other screen. Okay, so the p-value that we got from the test was 0.0818. That p-value is larger than 0.05. So in the end, we fail to reject the null hypothesis here. Now note, the alternate hypothesis was my claim, so the data does not, because it fails to reject the null, does not support the claim that teachers make more than 58,000 per year on average. Okay, so that's problem number 2. Okay, so in this problem we have a claim that the ACT composite score for someone accepted into Princeton is, the mean score is below 33. So first and foremost, this is a claim about a mean. Second, let's write the null and the alternate hypotheses. The null hypothesis, or the alternate hypothesis, is that it's less than 33. The null hypothesis is that it's equal to 33. Okay, because it is less than, this is a left tail test. Okay, so part D, because it's not a two-tail test, this is something that you can only solve using a p-value. Part E, because it's about a mean and we have to use a p-value, this is going to be using a t-test. So let's get that p-value for the t-test. Okay, so if I conduct this test, I am using statistics for a t-test. I'm testing against 33. The sample mean in this problem is 32 with a standard deviation of 1.5. The number in the sample is 50. This is a left-tailed test. So I calculate and I get a p-value of 1.02 times 10 to the negative 5. Alright, so let's transfer that over. Okay, so the p-value that I get here is 1.0235 times 10 to the negative 5. That p-value is clearly below 0.05, so we reject the null hypothesis. But remember, the alternate is our claim, so the claim stands here, so the data supports the claim that the mean of ACT scores for Princeton acceptances is below 33. All right, so let's look at problem number 4. So in this problem, we have that fewer than 50% of applicants were accepted into the University of Maryland. All right, so is this a claim about a proportion or a mean? We're talking about 50% of something, so this is a proportion. Part B. Write the null and the alternate hypothesis, right? So the alternate hypothesis is the claim that the proportion is less than 50%. The null hypothesis would be the equivalent statement that it is 50%. Part C. Is this left tail, right tail, or two-tailed? This is going to be left-tailed because that's a less than statement. Part D. Okay, since this is a left-tailed test, it has to be done using a p-value. Part E. It's a proportion test, so this is a 1 proportion Z test. Alright, so for part F, we actually have to run the test and come up with the p-value. So let's get the calculator for that. Alright, so we're going to do a 1 proportion Z test. We're testing against 50%. Our statistics here is that it's 110 out of 300, right? So 110 out of 300. This is a left tail test. We calculate, and our p-value is like 1.931 times 10 to the negative 6. So let's go and record that. Alright, so the appropriate p-value for this test is that p is equal to 1.932-ish times 10 to the negative 6. This has p being less than 0.05. So we fail to reject H null. Okay, so remember the claim is the alternate hypothesis here. So if we fail to reject H null, the data does not support the claim that fewer than 50% of applicants are accepted into Maryland. Alright, so that's all 4 problems. That should give you a good idea of how this works for a mixed bag of these type of tests, the kind of analysis you would have to do as you break down the claims. And we're there. Alright, so I will see you when we see each other. If you have questions, make sure you're emailing, doing them in drop-ins, and we'll go from there. Thank you.